Welcome back to the vectorsurvR video training series. This video is a continuation of the graphing training. If you have not seen that video, please watch that. This one starts directly off where that one left. That video went over the basics of ggplot. This video is going to focus on more advanced types of data mapping as well as more advanced graphs and methods of styling and customized themes. So let's start by calculating our anomaly for the sample collections. I run that here. And then I create this bar line plot combination. And this is where we can use the same data from our ggplot function, but then we can map it to different outputs on our graph. My default data is going to be the abundance anomaly, and then my default mapping is X is mapped to bi-week and Y is mapped to my abundance. I add a column component to create a bar chart. So if we just run this portion, this is what this will look like. Notice that the fill of my bar chart is not dynamic. It's not changing based on the abundance value. And that is because I left it out of the aesthetic. If I wanted to have it do that, I could. I would just have to include that here in this aesthetic mapping. But in this case, I just want to have a light blue looking graph and I want it to be somewhat translucent. And so I have left these parameters outside of my mapping and I fill them with light blue and alpha equals 0.7. I do the same thing for geom point and geom line, except now I'm mapping them to the 5-year average value. So if you recall, the anomaly output includes the abundance of the target year, the 5-year average, and the delta value. We run this. Notice there is no legend, even though I have tried to label my legend like how we did before. There is no legend that appears, and that is because the labels labs function refers to things that have been mapped within our plot. Because we don't have any mapping, we can't simply just label it. We actually have to create sort of a custom guide, and I'll show you guys what that means and how we do that. So this here can be modified and styled with a unified legend. I'm going to show you guys what this final chunk of code, and I provided this so that users can reference it in the future. It is kind of complicated, but I'm going to go over each component of it to help people better understand what can be done. And this is what the output in the end looks like. If we just take this first portion here, the default data is anomaly, and I make it so that the default mapping for the aesthetic is X equals bi-week. I don't include Y in this follow-up graph because Y changes based on the geom of interest. However, because they all reference back to this original ggplot mapping, but as the default, I don't have to do that, so it already knows that X is equal to bi-week. So for this first portion here, notice that I added a fill and a color in my aesthetic, but I did not map it to any particular data. Instead, I mapped it to a character value, and this is the value that I want my legends to have. So I want any fill value based on my geom column to be the 2020 abundance, and I want any color to also be 2020 abundance. And if I just to run this, notice that this fill color is not blue. It's because it doesn't know what color it should be. But we have a fill portion in our graph, and we have a color portion. Now, if I then include geom point and geom line for my 5-year average, where I see I mapped the Y to 5-year average, I then tell it that I want color to equal 5-year average in my mapping aesthetic. And I do the same thing for the lines so that these match. And if I was just to run this now, we see that a legend does appear by default, but it's not what we wanted above. Actually, the colors seem to be backwards here, and that's just because it's going off of a default color scheme. But we almost have what we want, but this would be perfect if our 2020 abundance was above and the line was the right color, and so we can customize this. So now our So now the actual labels of what we want to be plotted are technically correct, but it's not plotting what we want to show. And so we can add in the label titles now, and you will see that something does show up for each of them because there is a mapping. However, the colors aren't right. So what we can do is that we can actually manually fill the colors on the color scales. Every time we have a color or fill aesthetic, just like the X and the Y axis, they all have their own scale. And so here I tell it scale fill color manual. I say if a mapping value is 2020 abundance, make it light blue. If it is the 5-year average, make it red. And this is for the color portion. So this is going to affect the outline of my bar chart and the line of the line chart, as well as the point color. Then I tell it scale fill manual, and I tell it 2020 abundance is going to be light blue. Now, if I run just this here, it's going to look how we want. In terms of the plot itself looks correct. However, the legend is not quite right. The fill legend and the color legend are two separate legends here. And so we don't actually, we want the contents of this fill legend to show up here appropriately, but without having two splits or two split legends. And so to do that, we can actually use a manual guides. And so we use this guides function, and this allows us to look at the specific legends for our aesthetics. And what I do in this is that I actually get rid of the fill legend. So I say we don't need this upper legend. So I say none for fill, and that's what this does. And then I say I want a manual color legend, and I want it to be equal to color guide legend. So I override the aesthetic, and I let it be equal to a list. And then I tell it that I want this first component of my color legend. So notice we have two parts to our color legend, and it knows that. I tell it the first one I want it to be light blue on the fill. The second one has no fill, and I want it to stay just as it is. And so if we just plot this, we will end up with the same plot we had above, but now with a legend that is appropriately labeled. So I add in some additional styling on this graph. So one thing I add here is that I add a theme plot title element, and I adjust it to the right. So whenever you reference theme, you're specifically talking about the look of your graph other than the data that it has contained within it. So I tell it here that theme plot title. So I focus on my plot title, and I want it to be, it's a text element, and I adjust it a 0.5, half an inch to the right. So we just run this on top of this whole graph. We'll see the adjustment has been made. So like before, when I said whenever you have an aesthetic, you have this scale color manual, I could do the same thing with my X and my Y axes. And so because they are continuous values, meaning that they are numeric and they're not discrete, we can use the scale X continuous and scale Y continuous to adjust the number of breaks or the values on our axes. And so here, I tell it that I want it to be a sequence from 1 to 26, and the default sequence function has separated by a 1 increment. I tell it that for the x-axis, and then I say for the y-axis, I want it to be 0 to 60, and then I want it to be broken up by increments of 5. And that is why when we run our final graph, we have an appropriate looking legend, and then our bi-week ticks are all shown, and then the abundance scale has more detail added as well. And so you can change this however you wish, but this is just a sample example for how styling works in ggplot. So of course we can do the same thing we did above with fauceting this, and I just added a faucet wrap to this based off of species. And this is based off of the first graph we showed. And so this is just an example of you can faucet wrap values of many types if you really want to get a better comparison for data analysis. And so here in this sample graph, you'll notice that I faucet wrapped on species and I plotted our delta, but then I used a conditional on my delta to specify whether or not it was negative or positive. You can do this in many, many graphs to specify if you want a certain color to show up or if you want something to be marked above a certain threshold. For this graph, I made sure that X for the month is a factor. And that way I'm able to then label it based off of this scale X discrete labels function. And so if we recall that I use scale X continuous for this previous graph because the scale of the X value was a continuous numeric. Well, in the case of this graph, the X value is based off of the month value. And I could tell it that that's discrete. And so I actually say I want it to be discrete, and I use this month ABB, which is the abbreviation vector for months in R. And if we just run this portion of the graph, it looks like that. Now, as opposed to 1 through 12, I actually have mapped my x-axis to include the month name abbreviations. So the other thing to point out on this graph is that I have mapped my y value to the delta, but then I've mapped the fill value equal to a conditional. And whenever you use a conditional in a ggplot, it's going to separate your values based off of true and false. And so here I say fill equals delta is greater than or equal to 0. And so I'm telling it I want to fill on the condition that delta is greater than or equal to 0. And so it's going to then separate out my data. So if you notice here, when I did that, it separated it out based off of false and true, where false is the first portion of the vector and true is the second portion. And this is saying that if delta is greater than or equal to 0, we color it one color. If it's not, we color it another color. But I want these colors to be specific to my graph. And then because I have these with different species, I want this to wrap on different species because I have separated out the calculation. And that's what this portion does. I then use this scale fill manual because I want to manually change the scale for the color filling. And since we have false true as our vector order, and so I actually tell it that I want my fill scale to be named delta, as opposed to this delta is greater than or equal to 0. And then I specify I want my values, so these color values, so I want things that are considered this first one, so that would be things that are false to be salmon colored, and then I want things that are true to be colored light green. But I want my labels, as opposed to being false and true, to be negative, positive. And then finally, I add in a faucet wrap around my species because I have separated out my species. And so the final looking graph is that everything that is positive is colored green while negative is colored red. And I can actually change the order in the orientation of this legend, but what I wanted to point out is that we can actually conditionally fill and change our graph. Now, if I was to do this on the y value of delta, it will still give us a true or false, but it will actually filter out our data in a way that we don't want. So just be aware of what you are mapping to when you are making these types of plots. I show an example of our infection rate. And so if you hear, I use sample pools to calculate our infection rate. I filter out 2015 and 2016 as my years, and then I am going to plot this with a lot of the similar techniques used above. For one is that I make sure that my plot here has month labels, and then I also include this additional layer that's called error bar. That is because if you recall, the infection rate has a confidence interval portion in the calculation, and I want that to be included within my graph. Now, of course, I make sure that my x is discrete, so I assign it to be a factor, which is like a character value in R. And then I do the same thing for my color. I actually decide I want it to be colored based on year. And then because we have multiple years with the same X value, so we have 2015 has a month, the same months that 2016 has, I actually tell it that I want it to group by this factor year. And this is going to allow us to connect the year lines on the graph. Furthermore, I add in an error bar, and this allows us to assign a minimum and maximum confidence interval to our aesthetics. So our lower and upper confidence intervals can be assigned. I include some some position dodging so that our points aren't overlapping. And then I add in geoPoint. Now this is going to map from our original ggplot mapping. So our point and our line are both going to look at our the infection rate, with X being the month and Y being our infection rate value. And then I add in my labels. And if we run this graph, the years are all grouped together. And we see our infection rate with error bars and each point estimate within our graph. Now, if I was to take out this group portion, we're going to see that the plot gets confused. It doesn't know if it should connect these points or not. That is why this group portion can come in handy in terms of letting us know exactly what should be added and where. Now, you might notice that I've been adding quite a few different things within these plots. Occasionally I'll add a theme portion as above, or I'm adding a scale or specific elements. And sometimes it can become a lot to do this every single time. For example, if you wanted your title here to always be positioned, you can do that by creating a custom theme. And ggplot actually has several built-in themes. So if we run this theme function, that if you recall, we used this above to readjust the position of our title. We run this, we can see that there are several complete themes that exist within ggplot, but you can also customize your theme in accordance to all of these different values. And that's a lot of different things that we can do. And so here, let me just show you guys this plot here. So and I assigned this plot, I called it my plot, and I did that up above when I assigned it equal. I can do my plot and I can add in one of these pre-made themes. And so access them by doing theme underscore, and I say, let's just do theme light. Now we have the theme light added in on our plot. And so this theme, maybe we like this theme, but we want to add things to it, and we can do that. And so what I did here is I say, I like this theme light, but I want it to be a bit different. And so in this down here, what I ended up doing is I say, okay, theme light, great. But I want my legend position to be on the bottom as opposed to the right here. And so I can do that because that is something that is available in our theme function. And then I also tell it that I want my plot title to be adjusted to the right. I also tell it I want the font of my plot title to be size 20. And then I specify that my axis X title, I want that to be a bit larger. And then I tell it that I want my axis text to be boldface. And so this is more for an example. So I assigned all of this, added together to something called my theme. Now, if I go back up to my plot here, I say plot plus my theme, you can see that the updates I made have been applied. In the x-axis here, everything has been boldface. My legend is on the bottom. Month is size 20, and title has been adjusted. Of course, you can do this however you wish. You might not want these specifics. This is just showing how you can do and what you can do here. And now I added another one where I also adjust the title, but in addition, I take the axis text and I put it at an angle. I make it bold and then I make it a bit larger. I'm showing this because sometimes you will run into a graph where your axes labels will start overlapping with one another, and it can get very annoying or very difficult to read. And so you might want to just have this or keep this on hand so you know that you can actually make these specific to an adjustment. And so I actually added both of these themes to the sort of basic abundance bi-weekly plots, just to show you guys what this would sort of look like more up close. And there's lots of things you can do to customize in ggplot, and I recommend looking into some of the more advanced elements here, but this is just an example of all the kinds of things, some of the things that are available to you. And The final thing I'm going to go over is that we have this plotly function. So you might want to create an interactive version of your plot. Every ggplot, if you have plotly installed and loaded, can be run using ggplotly. So if you recall, I assigned the plot above to be my plot. So I can run this ggplotly function, which comes from the plotly library. And when I run that, you get an interactive version of the plot, which can be very helpful for determining specific data points or exploratory data analysis. I mostly use it for exploratory data analysis. This sort of plot will not show up rendered in a PDF or in a Markdown file because it is an HTML wrapper function, but it can be very useful for identifying species or identifying problem areas in your graphs. As well, it can be fun just to mess around with the figures and get better idea of what's going on in your data. So I hope this was helpful today. And next time, we're going to focus on spatial data and how to plot spatial data on maps, as well as how to integrate this into a larger report. Hope to see you guys next time. Take care.